Okay, so question 17 was answered. That is, adding two binary numbers has been successfully completed. And now we need to follow, let's see, question 18. In question 18, let's see what it says. Question 18 says that we need to write a Java program to multiply two binary numbers. Okay, so that's what we're going to tackle now. Now, I looked up how to multiply binary numbers. Here's the binary multiplication rules. It says binary multiplication is similar to the multiplication of decimal numbers. We have a multiplier and a multiplicand. The result of multiplication results in a product. Since only binary digits are involved in binary multiplication, we get to multiply only zeros and ones. The rules for binary multiplication are as follows. Multiplicand and the multiplier, 0 times 0 equals a product of 0. So multiplicand 0, multiplier 1, 0 times 1 equals 0. Multiplicand 1 and a multiplier of 0, 1 times 0 equals a product of 0. Multiplicand 1 and multiplier of 1 is equal to 1 plus 1 times 1 and is equal to product of 1. So at this point of the operation, there's no carryover. However, after you multiply, you need to add. So how to multiply binary numbers? The process of multiplying binary numbers is similar and easier to do than decimal multiplication, as binary numbers consist only of two digits, which are 0 and 1. The method of multiplying binary numbers is given below. The same set of rules also apply to binary numbers with a decimal point. Let us take the example of multiplying 101 of base 2 and 1001 base 2. The decimal equivalent of 11101 base 2 is 29, and the decimal equivalent of 1001 base 2 is 9. So let us multiply these numbers. Step 1, write down the multiplicand 11101 base 2 and the multiplier 1001 base 2, one below the other in proper positions. Multiply the rightmost digit or the least significant bit, LSB, of the multiplier 1 with all the digits of the multiplicand 11101 base 2. 3. Add a placeholder of 0 or x. Actually, those are, 0 or x. Before multiplying the next higher order digit of the multiplier with the multiplicand. Step 4, repeat the same process for all the next higher order digits until we reach the most significant bit, MSB, which is the leftmost digit of the multiplicand with the multiplier. Step 5, the product obtained in each row is called the partial product. Finally, the partial product. Finally, add all the partial products to add all the binary numbers use the rules of binary addition. And here we go. The rules for binary addition are listed as follows. 0 plus 0 equals 0. We already know this because we already did the addition. 0 plus 1 equals 1, and 1 plus 1 equals 0 with a carryover of 1. And we already know that because in the original code, we have it. And we are going to swap first to the IDE and switch the screen so we can see it. Okay, which actually, by the way, I renamed my class. I renamed it question 17 because I was answering question 17. So instead of binary 3, now it's question 17, as we know. It is adding, and there's a carryover here in line 33 or up here in line 10. There's the carryover array, which is size 1. Okay, with index of 0 at all times, because it's just using it as a carryover. Now, back to, let's take a look. Let's look at the class, because I didn't show you. Line 10, right here. Carryover Okay. Index 0. Okay. So let's go ahead. Let's go ahead and switch. Let's take a look. And now we're looking at the visual representation. Okay. Oh, it says so 1 plus 1 equals 10, and 1 plus 1 equals plus 1 equals 11, and the binary in the binary number system. So this is the visual representation of the multiplication with the addition, following addition. Okay. Multiplicand on the top, multiplier on the bottom. First, we go through the first number 1 times 1 times 0 times 1 times 1 times 1. Okay, and here it is. 1 times 1 is 1, 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 and 1 times 0 is 0. So there are no carryovers when you're doing the multiplication. Carryovers only come in on during the addition phase of the process, right? During the summation of the numbers. So here is line 2 with the first x, which is 0 times 1, 0, 0 times 0, 0, 0 times 1, 0. So anything you multiply by 0 is always 0. Okay, as it says over here. And 0 times 1 is always 0. Anything you multiply by 0 will always be 0. Okay, and then we follow the next step. So rules for binary multiplication, rules for binary addition. Okay, it's all down there. Pretty neat. Okay, pretty neat. This is at Q math, as you can see. Okay, and now we're going to write down some of the steps that are necessary to create our code. So sort of a algorithm or pseudocode. We'll get into that. I might not finish it completely in this video, but I will make another video immediately, only because I have to switch order soon. So let's see. Let's pause. Okay, so let's continue. Let's continue and let's see. Let's bring the nodes. I got to do some nodes now. And let's take it. All right, so let me bring this over here because we are going to need to do some writing now. We're going to need to do some writing. Okay, that's much better. Okay. So multiplication rules. Things. This is how we always prepare for the program. I find out it's the easiest way to get things done and getting them right, and it will keep you from having to overthink things. So always typing a rough sheet, right? What do you call that? I forget the word. Start writing down your ideas and planning how you're going to develop the program. Things in mind, pseudocode, and then some test code, alpha code for that. So let's take a look. So things to remember. Okay. I like to use bullets. Multiplication to or by 0 is always produces 0. Okay, this is important. This is important. You have to, even the smallest details, you gotta write them down. Okay. All right, now because we have to, okay, multiplication of 2, 1 by 1, it always produces 1 with no carry. Okay. Let's remember. So that's the first part. Now, second thing to remember. Okay. Okay. Multiply the rightmost digit or least significant in the multiplier with all digits of the multiplicand. Okay. So let's write it. Multiply the rightmost, or let's say the first binary digit. I write it in your own words, make it easier. First binary digit for all members or times all times each member of the multiplicand binary number before one number. Okay. Okay. Multiply, let's say multiply each multiplier binary digit times each member of the multiplicand binary number. Okay. First. Next step is to write down, okay, the numbers below, like a sum. That's the next thing to keep in mind. So okay, it's here. So place each partial product below the product of each multiplier times each multiplicand below each other and one of. I hate this format. Okay. And one space to the left. Okay. Or leaving blank the first space directly below the first partial product of each multiplication, as in the addition of numbers after multiplication. Boom. Okay. And remember. Okay. Let's see. What is the next thing that we need to remember? Let's find out. Okay. Carryovers. Follow the rules of binary number addition and remember to remember that 1 plus 1 equals 10. So, and we carry over the 1, okay, onto the next binary addition. completion. Okay. All right. So that's the first thing. Those are the things that we got to remember right away. Okay, I can't think of anything else right now. Now, because we're going to uh, start developing, or before we start developing the program, we read the things to remember, and it's a good thing to decide what variables you're going to use based on the things to remember. So let's say variables needed. Okay, you might need more than that, but this will give you the basis, right, to start the platform. Okay, binary number. Okay, multiplicand. Okay, let's say the binary multiplicand. So we can call that being call it multiplicand. Okay, we call it an array. They need to be arrays. We can do this here. Use arrays to, okay, for the binary multiplicand, use array for the binary multiplier, use arrays for each each row of partial, oh, excuse me, each row of partial products. We're gonna need to use a row for each partial product because we're gonna need to add them all, right? We're gonna need to add them all. On this one, let me show you here. I want to show you. Okay, so on this code, all right, so let's put this away. Okay, so on this code, we have this is mimicking a sum, right? There's actually no progression of sum or addition going on in this code, but this code mimics the addition of binary numbers. So in this code, it is comparing the positions, the index among two binary numbers in order to mimic, they're in line 24, in order to mimic the addition by using logical operations, which are just below the if statement on line 25. Okay, or what I'm highlighting here, these are the operations, including the other else statements. So these operations here of depositing a number index into an index of sum, which is actually the partial sum, that is a partial sum until it is completed. That mimics the operation of addition, right? Because it's moving the numbers based on where they should be if you were adding them. Okay, but I'm comparing two binary numbers only on line 24. Okay, and we're going to use nested if statements to compare more binary numbers. Okay, or because when we're doing the addition, we're going to have rows per the size of the array of the multiplier, because each index on that array on the multiplier array has to be times each index on the multiplicand array. Okay, so given that in mind, we're gonna have to use nested if statements if we're going to use the same program, the same logic, to test the value of the first, second, third row of the multiplicand. Okay, so that's another thing to remember. So there we go. Let's go over to our thing here and here. Okay, use arrays for each row of partial products. Okay. Use array for final sum. Let's just call it for sum of partial products. Okay. Use nested if statements. Forgive the noise. Use nested if statements to compare, mimic the addition of the partial products. Okay. Okay. What is this? Let's say that it is int array. I like to separate. No, we can do it like this, but it looks kind of funny. That's why I do it like this. Multiplicand, right? Multiplier. This is easier to read. Why does it look like it's not? Well, let's do this. And multiplier. Okay. And depending on the number of the array, let's say that we use 7. That's a lot, but we're going to do it anyway because we're going to challenge ourselves. So let's say that we have to, okay. Okay. Let's see. So let's say we're going to do this here. Oops. Okay. Variables to create. Let's just name that like this. Okay. And here, things to remember. Okay, I was going to write something there and I forgot. Okay. Okay, I'll come back to that. Oh, sum of binary numbers is always lengthier, okay, than the binary numbers added or multiplied. Okay, so the arrays needs to be, so the sum, the partial product arrays need to be lengthier. Let's just copy that here. Okay. The sum array needs to be lengthier and the numbers to add or multiply. That's another thing to remember. So arrays for binary multiplicand, arrays for binary multiplier, arrays for each row of partial products, array for okay, arrays for sum of partial products. Okay. Okay. It's my own style. We make the addition of the partial products. Okay. This should be here. Okay. You're gonna have to ignore the music in the background and the noise. It's what it is. Okay, so let's do something. We're going to continue this. The video is getting larger, so we're going to continue this a little later because there's a lot of noise now. So we will come back. Let's get good.